All right, course 3, welcome to lesson 41. Lesson 41 today we are going to do something called functions. This is the slope-intercept formula, although we're going to do it pretty simply, and as you can see, this is going to involve just a little bit of graphing on our part, so we want to, we're going to be doing some paying attention with our graphs. So we're going to have to be careful when we write these out, and I'm trying to switch my thing because it won't move for me, and that's going to make me upset. Alright, course 3, I took some time to get this to change because I couldn't get it to do it, but thanks for bearing with me. Here's a function, p equals 4s. This is the perimeter of the square. It's a function. There's an input number and an output number. So whatever we input for s, and we multiply it by 4, we get an output, which is phi, which is p. I just can't talk. So when we do that, we can make a table to show that p equals 4s. And we can do that by indicating what things are. Now, whatever we change, s and p, we can determine different things. So if s is 1, then p is 4, because 1 times 4 is 4. If s is 2, then p is 8. If s is 3, then p is 12. Now, if you notice, I got out a coordinate plane. And you're like, oh, great, he's going to make us do some coordinate stuff. And the answer is, yep. So we could also graph those out. Let's graph them out then. 1, 4. And 2, 8. 2, 8. And then we could graph out 3, 12. 3 and 12 is way up here, so I lost my line. And then what we would do is we could graph those points out all in relation to 0. Okay, now I notice my screen moved when I changed things around. But notice it's a real steep line. Okay? So that's simply all we do. Pretty easy. Now, if I could just get, let's see if I get that line to go away. There we go, line's gone. Yay. All right. Now the perimeter of an equilateral triangle is 3 times the length of one of its sides. 3 times the length of one of its sides. Write the equation. Well, that's p equals 3s, 3 times the length of one of its sides. Choose 4 different side lengths. Okay, so we're going to make a table again, s and p. So let's choose 4 different ones. If s is 1, then p is 3. If s is 2, then p is 6. If s is 3, then p is 9. If s is 4, then p is 12. Right? Okay, pretty simple on that. I'm going to move this over a little bit so I don't want to do that. Move this down a little bit so I have it right there. Perfect. Okay, so now we graph. Now let's make a graph of those things. So let's graph them. 1, 3. 2, 6. 3, 9. 4, 12. Okay? And they're graphed. Notice that all our points line up very nicely. Let's try a few more. Look at example 2 on page 279. Xavier and Yolanda, weird names, are playing a game. When Xavier says a number, Yolanda performs an operation with Xavier's number and says the result. The table shows 4 numbers Xavier said in Yolanda's reply. So they got 4 numbers. Okay, you have 2 and 4, 3 and 5, 4 and 6, 5 and 7. Describe the rule Yolanda uses and write the rule as an equation, then graph it. Okay, so what's the rule? Well, it looks like she's adding 2 to each thing, so let's write it down. Y equals x plus 2. So whatever y is, it's x plus 2. Let's graph that. 2, 4, 3, 5, 4, 6, and 5, 7. Real steady graph. And if you were to graph that, then we could, and hopefully this doesn't change me. And it did. But I can graph a steady progression. But every time I click the line button, the screen moves on me. That's rather irritating. Okay, let's try a few more. Okay. If our graph makes a nice steady line, then we got a proportion showing up. Okay? But the one that we just did with Yolanda to Xavier's number, that's not proportional because you can see that things start to spread out. Let's take a look at a few more. Look at example 3 on page 281. The area of a square is a function of its side length. The graph of an area function is different from the graph of a perimeter function. For the function a equals f squared, because that's the formula for area of a square, describe the rule with words and make a table that shows at least 4 pairs of numbers. Okay? So to find a, to find area, we're going to square s. That's how we describe it with words. Let's make a table. So s and a. So when s is 1, let's start at 0. When s is 0, a is 0. When s is 1, a is 1. When s is 2, a is 4. When s is 3, a is 9. You can see now we start to take off. Let's graph it. 0, 0. 1, 1. 2, 4. 3, 9. Look how our graph curves and moves steeply up. Okay, it's not linear because we have a curve. Okay, since that's curved, and we know it's not linear. So since it's not linear, it cannot be proportional. All right, let's try a couple more. On page 281, we have Janos is playing a numbers game. When Zena says a number, Janos says a number that is twice Zena's number. Write the equation. Okay, the equation is Janos says a number, Zena doubles it, right? Or Janos doubles Zena's number, so that's 2x. 2 times what Zena says is whatever Janos wants. That's her equation. Make a table. X and y. So x is 0, 0. Okay? Zena says 1, Janos says 2. Zena says 2, Janos says 4. Zena says negative 2, Janos says negative 4. Because we're doubling them. All right? Graph it. 0, 0. 1, 2. 2, 4. Negative 2. Negative 4. Okay? You can connect the dots. As we graph those ordered pairs, okay, every point should meet the conditions of the game. To check it, we can add some more points to make sure that they meet the conditions of the game. Now, the last one we're going to do is the slope-intercept formula. And I'm not teaching the slope-intercept formula today, but this is how it graphs out to be. Here's the formula. Y equals 1/2 x minus 2. There's the formula. So how do we do that? We do this quite simply. If x is 0, then y must be -2. Because half of 0 is still 0, minus 2 is minus 2. If x is 2, half of 2 minus 1 is -1. So if x is 2, that gives me 1, minus 2, -1. If x is 4, half of 4 is 2, that gives me that y is going to be 0, because half of 2 minus 2 is 0. Now we graph them. 0, -2, 2, -1, 4, 0. You can see my line, I can't draw straight obviously, it's going to progress that way. Okay? I did not mean to curve that, but it's actually kind of hard to, there, that looks a little bit better. All right? Excuse me. That's simply all we're going to do. So in this lesson we have described functions with words and expressed them with equations. We have then listed them with pairs of numbers as options and then graphed them out. And we will be doing more with this in the future. So there you go. We'll talk about this in class tomorrow.